I am S.PREMA, Assistant Professor, Department of Chemistry, Theivanai Ammal College for Women. This is my presentation. Here I am going to discuss about Arrhenius theory and its limitations. The contents we are going to see here: introduction, electrolytes and non-electrolytes, Arrhenius theory of acid and base, postulates of Arrhenius theory of ionization, achievements of Arrhenius theory of ionization, limitations of Arrhenius theory of ionization. So the introduction of this Arrhenius theory is introduced in 1887 by the Swedish scientist Svante Arrhenius, that acids are substances that dissociate in water to yield electrically charged atoms or molecules called ions, one of which is a hydrogen ion, H+. H+ is the hydrogen ion, and that bases ionize in water to yield hydroxide ion. So acids neutralize in water to form H+ ion, and the base neutralize in water or ionize in water to form hydroxide ion, who got Nobel Prize in 1903 from the work on electrolytes. He focused on what ions were formed when acids and base dissolve in water. He came up with the idea that acids and bases dissociate in water to give hydrogen ion and hydroxide ion. Next, we move on to electrolytes and non-electrolytes. What is meant by electrolyte? Electrolyte is a compound that conducts an electric current when it is an aqueous solution or melted. In order to conduct a current, a substance that contains mobile ions that can move from one electrode to the other. Example: potassium ion and sodium ion. Okay, so potassium ion move from one electrode to another to conduct a electric current. Okay, so this is electrolyte. Next, non-electrolyte. Non-electrolyte is a compound that does not conduct an electric current in either aqueous solution or in the molten state. Many molecular compounds such as sugar or ethanol. So sugar and ethanol is the example for non-electrolyte. Okay, when these compounds dissolve in water, they do not produce ions. So electrolyte are dissolved in water to form ions. Okay, and non-electrolyte dissolved in water, they do not produce ions. So this is the difference. Okay, next, Arrhenius theory of acid and base. Arrhenius acid in the aqueous solution increases the concentration of protons or H+ ions. So protons or H+ ions both are same. Okay, wow? So the Arrhenius acid is the in aqueous solution, it increases the concentration of H+ ions. For example, hydrochloric acid in the water. Hydrochloric acid means HCl undergoes dissociation reaction to produce H+ ion and Cl- ion. As explained below, HCl in this equation, HCl gives H+ plus Cl- in aqueous solutions. Okay, so the concentration of the H+ ions is increased to form a hydronium ion. H+ ion, it will increases in Arrhenius acid. Okay, Arrhenius base is a substrate that increases the concentration of hydroxide ions in the aqueous solutions. Hydroxide ion means OH- ions. The example for Arrhenius base is highly soluble sodium hydroxide. Sodium hydroxide means NaOH in aqueous solution to dissociate to give Na plus OH minus. Okay, this OH minus ion concentration will increases in the substance that is known as Arrhenius base. Okay, which dissociates to give sodium ion and hydroxide ion. Next we move on to postulates of Arrhenius theory of ionization. the molecules of an electrolyte in solution breaks up into two types of charged particles called ions. This process is known as ionization. Okay. The positively charged ion is called a cation, you know very well. Okay. While negatively charged ion is called anion. Okay. In the electrolyte solution, the molecule will dissociate or break into two types. One is cation, another one is anion. Cation got positive ion and anion is negative charged ion. Okay. Next, for example, when sodium chloride is dissolved in water, it breaks up into Na plus and Cl minus ion. The Na plus ion is called cation and Cl minus ion is called anion. So, NaCl on ionization to form Na plus and Cl minus. Na plus is cation and Cl minus is anion. This is the first postulate. Totally we have 5 postulates. And applying electric current, second one, to a electrolytic solution, the positively charged ions move towards cathode and are called cations. So, in the electrolytic solution and applying electric current, okay, the charged ions, that is positively charged ion move towards positively charged ion here Na plus, okay, Na plus move towards where? Cathode. Okay, so this ion is called cation, while negatively charged, that is Cl minus ion, move towards anode, that is called anion. Okay, va? This is anode electrode and this is cathode electrode. And third postulates, the total charge presented on the cation is equal and opposite to the charge of anion, so that the solution as a whole is electrically neutral. So, the positively charged Na plus and the negative charge Cl minus both are equal. Okay. So, this in this solution it is electrically neutral. This is the third postulates. And fourth one is the oppositely charged ion formed, it will completely reunite to form undissociated molecule and a dynamic equilibrium. This is dynamic equilibrium always exists between the dissociated molecules. Such equilibrium is called ionic equilibrium. So, the molecule will be dissociate to form A plus and B minus. This is the dynamic equilibrium. Next, fifth postulate, the extent of ionization is expressed in terms of the degree of ionization. The degree of ionization is defined as the ratio of the number of moles of ions to number of moles of undissociated molecules. Mathematically, it can be expressed as degree of ionization is denoted as the symbol alpha is equal to number of ionized molecules by total number of molecules dissolved in solutions. Next, achievements of the theory. Differentiate electrolyte from non-electrode. This is the achievements. First one, differentiate electrolyte from non-electrolyte. So, you know electrolyte solution and non-electrolyte solution. Next one, explain conductivity of weak electrolytes. It will explain only the conductivity of the weak electrolyte. That is the one of the achievement of this theory. Third one, it describes mechanism of electrolytes and ionic reaction. And fourth one, it explains heat of neutralization. What is meant by heat of neutralization? Heat of neutralization is nothing but how much of heat is evolved during the neutralization of acid and base to form salt and water. So, heat of neutralization is denoted as delta H. Okay, it is expressed in kilojoule per mole. So, generally it is exothermic reaction. So, delta H is always negative. Okay, these are the achievements. Next one, limitations of Arrhenius theory of ionization. So, first limitation, it does not explain how ions are formed. Okay. Second one, it does not explain strong electrolyte conductivity. So, it explain only weak electrolyte conductivity. So, does not explain the strong electrolyte conductivity. and it does not explain equilibrium constant for strong acids. So strong electrolytic conductivity does not explain. So equilibrium constant of the strong acids is also does not explain this theory. Okay, and it fails to explain the variation of transport number with the concentration. What is meant by transport number? It is also known as transference number, that is the mobility of ions during the electrolytic solution. So the concentration of the transport number is does not explain. Okay, and does not explain the for variation of conductivity with the concentration of strong electrolytes. Okay, variation of conductivity means the temperature of the solution, the number of the ions and the nature of the electrolyte. These are all the variation of conductivity. Okay, with the concentration of strong electrolytes does not explain this theory. Thank you.